Determine the concentration change of H2O2 at 400 S. From the provided data table, the initial concentration of H2O2 at T equals 0 S is 2.7 molar. The concentration of H2O2 at T equals 400 S is 1.7 molar. The decrease in concentration, the amount reacted, is delta H2O2 equals 2.7 molar. 1.7 molar equals 1.0 molar. Calculate the moles of H2O2 that decomposed. The volume of the aqueous H2O2 solution is 1.0 liters. Using the definition of molarity, moles equals molarity times volume. Moles of H2O2 reacted equals 1.0 moles per liter times 1.0 liters equals 1.0 moles. Use stoichiometry to determine the moles of O2 produced. The balanced chemical equation is 2H2O2 gives 2H2O plus O2 quad. The stoichiometric ratio shows that 2 moles of H2O2 decompose to produce 1 mole of O2. Therefore, the moles of oxygen gas produced is 1.0 moles H2O2 reacted times 1 moles O2 over 2 moles H2O2 is equal to 0.50 moles O2. Calculate the concentration of O2 in the collection flask. The produced oxygen gas is collected in a previously evacuated 10.0 liters flask. The concentration of O2 in this gas flask is concentration equals moles of gas over volume of flask equals 0.50 moles over 10.0 liters equals 0.050 moles per liter. Estimate the final pressure using the provided conversion factor. The problem states that 1.0 mole of gas in 1.0 liters, a concentration of 1.0 moles per liter, exerts a pressure of 24 atmospheres at 300 K. Because pressure is directly proportional to concentration at a constant temperature, P equals N over V, RT, we can use a direct proportion to find the pressure of our sample. P equals 0.050 moles per liter times 24 atmospheres over 1.0 moles per liter equals 1.2 atmospheres. This matches option A. The correct answer is option A, 1.2 atmospheres.